topic of panel discussion is excitement of science. ನಿಮ್ಮನ್ನೆಲ್ಲ ನೋಡ್ತಾ ಇದ್ರೆ ಅಷ್ಟೇ ಒಂದು ಉತ್ಸಾಹ ಕಾಣಬೇಕು, ಕೂಗಾಡಬೇಕು, ನಿಮ್ಮ ಮುಖದಲ್ಲಿ ಅದು ಕಾಣ್ತಾ ಇರಬೇಕು. There are three qualities of science. The first quality is the excitement of science. The second quality is the sweep of science. And the third is the incompleteness of science. Today's panel discussion topic is excitement. When we say excitement of science, it need not always be rocket launching excitement of engineers or life and death excitements of doctors. Excitement of science could be intellectual excitement, that is the thrill of following out a chain of reasoning for oneself, or the pleasure of watching several strongly individualistic personalities argue about their deepest convictions. Yesterday we observed this during the panel discussion. In other words, it is like the thrill of reading a science fiction by Dr. K. Ganeshaya and the pleasure of watching a play by Dr. Girish Karnad. Now we have three panelists with us. Dr. Kshitish Acharya, a senior scientist, Institute of Bioinformatics and Applied Biotechnology, Electronic City, Bangalore. And we have Dr. Naveen Sharma, Head Resources and Planning Center for Cellular and Molecular Platforms, NCBS, Bangalore. And Dr. M.B. Rajani, Assistant Professor, Humanities, NIAS, Bangalore. We'll introduce each one of them. We heartily welcome them and we are going to make their presentations, and at the end we'll have discussions. Dr. Kshitish Acharya K. At present, he is faculty scientist, IBAB, founder director, Shodhaka Life Sciences Private Limited. He is also a guest faculty at the Center for Human Genetics, St. Joseph College and JLCA SR, Bangalore. Has been a visiting faculty at University of Sydney and an adjunct professor at MCOP, Mahe, Manipal and IIT, Bangalore. He did his BSc with first class in biology and chemistry from the Purna Prajna College, Udupi, MSc with first rank in zoology from the Gulbarga University, and he was awarded merit scholarships and gold medal. He was awarded PhD by Banaras Hindu University for his doctoral thesis, Primer Phenomenal Influences on Pregnancy, Oestrus Cycle and Sexual Maturation in Laboratory Mouse. He was awarded CSIR NET-based JRF for his doctoral research. Coming to his research experience, he has adopted various research approaches including computational methods, genomics, transcriptomics and molecular biology for over 28 years. He has more than 210 citations, H index of 8, I-10 index of 7. He has worked in more than 6 Indian universities or institutes and University of Virginia, USA for 3.5 years. He has identified new candidate markers for non-obstructive azoospermia and developed several useful databases and novel computational methods. His industrial experience includes his exposed to industrial scale operations while working in the bioprocess core lab with a large fermenter in the cell biology department, University of Virginia. He joined Yashraj Biotechnology Limited, Mumbai in 2002 as a research unit head, soon appointed as the head of the production unit that purified specific proteins from clinical samples. He established the Shodhaka Life Sciences Private Limited in December 2008. He has also gained indirect industrial experience via interactions with the corporate sector via many informal and formal interactions over 15 years of work at IBAB. His teaching, training and research guidance experience includes about 3,000 hours of teaching a variety of topics at IBAB and other academic institutes as part of regular courses for about 15 years. He has given about 50 invited talks in national and international conferences, designed and organized a total of about 50 short courses and workshops. He has often was voted as the best teacher. He has successfully guided 2 PhD students to completion at IBAB. 3 doctoral students are being guided at Shodaka Life Sciences Private Limited, and he has also guided about 100 research interns. A specially for postgraduate diploma program in molecular biology methods was identified, and a 14-month diploma planned by him. The curriculum was designed and the course conducted for 8 batches. From selection, course organization to placements, all responsibilities were handled by him. For all 8 batches, an average placement achieved was greater than 95%. He has reviewed about 25 research papers for journals such as Bioinformatics and Nucleic Acid Research. He has also reviewed research entrepreneurship grant applications for various organizations. I request Dr. Kshitish Acharya Ki to come over to the dais, and I request Ms. Divya to present him a bouquet and welcome for the program. Dr. Kshitish Acharya, please. Why science excites us and how to go about exciting our young minds, young people to be very active in research. So please, floor is yours.
Set a timer first so that I don't go through time, not to deprive of time for our friends. We are a little late also. So I'm supposed to speak for 20 minutes. So before I start, I am a very forgetful person, so I should thank the organizers and thank you all for being here. It's a nice experience always to talk to young minds. And I see there are a lot of preparations done and a lot of nice events have happened, and you had a panel discussion and your teachers were telling. So I hope I will do justice to the events that are happening and the excitement you all been having. The topic that we have taken is excitement about science. And I did not prepare any slides. I thought it should be easy, because I have had a lot of excitement in science, and I'll just share my experiences. Okay? So I will share my stories. Is that okay? Yeah. Story number 1. Why did I take science? I will be honest. There's no specific reason. I don't want to lie to you. Probably most of you also drifted along, and somebody told me, you have scored reasonably well and you seem to be asking good questions, so you should take science. And my father said, you are a very mild person, so don't get into anything else, get into science. And maybe you would be good as a teacher or somebody, or maybe a postman or some post officer or something, but nothing where conflicts are there, so that's another reason. So like this, different reasons were there, and I did like science. It's not that I don't like, but actually I liked arts more. I used to write Kannadalli kavite, kate ಎಲ್ಲ ಬರೀತಾ ಇದ್ದೆ. Don't worry, I will not read my poems. So but nowadays actually I'm neither a Kannadiga nor a Tulu person nor a English or Hindi person. I speak everything a little bit, so I'm lost that way. So science is my only language nowadays. So I started PUC, and then somebody says, after PUC what? So you have to have either great scores in different places, or you can pay donation and get into engineering and all that. So I am very against donations. I was an idealistic fool, and even today I'm perhaps one. So no donations, I will do BSc, I told my father, and the fees were very high in engineering and other places also. So I took to BSc, and but then something else happened with me. I fought with my father and I told, education is meaningless. You know, people go and we sit in the class, there were 180 students in 10 plus 2 level, and I was last bencher. And people will come and teach, and I will sit there in the back. Nothing was making sense to me. And I said to my father, I don't want to, but he blackmailed me very nicely. He said, see, look, my father passed away very early, I did not have a good education. At least for my sake, please do a degree. And I thought I decided actually, I thought about that carefully, and I decided to do a big sacrifice in life and do BSc for him. But then, having decided to do that, I wanted to use the time in the classes. I was restless and frustrated because I'm not able to connect to the education system. I decided when I have to sit now for my father, I have to still make use of the time, and that decision, there are a lot of things that changed my life. I started understanding a little bit science. And then things happened, and I liked animals, so I did MSc in zoology. And I learned certain things in the classroom, but actually looking back, it was all exam-oriented learning only. Little different, I was a little different from others because I was scared of the degree Master of Science. Even degree Master of Science, and then Master of Animals, zoology also I did not know very well. And I decided I will be master of one chapter. For my own sake, right? Nobody told me to do this. For my own sake, I decided to read Platinum in this chapter and read every book possible out there. I used to go and surprise the librarian. He was like, sir, nobody has read this book. You are reading this. This is so surprising because I'm very blessed because nobody has read this book. I hunted down the books and I read. My teachers did not know. Nobody knew there were books existing. I read. I made one record of my own. I used to go around with that. Right? No, because just, it's an ego boost. Nobody else knows about this. I know this stuff. I don't know why I did it, but if today I'm a reasonable scientist, it is because of that. The assignments given in Western universities, they are of so value, I realize that today. Self-learning is an asset that we have to inculcate in the early days. And I unconsciously did that. Learning by self. Today I remember something about what I read, some things I forgot. Doesn't matter, but I trained my mind in the right direction. And that's changed. Even I did my MSc in Gulbarga University. Not a great place like where you are focused and things like that. But there were good teachers, some, and that helped me. But most importantly, this exercise helped. Then I went to PhD. Because this is a river, right? So you do this, and then this, then this. So what do you do? Okay, PhD. And I went to Banaras University. I landed up, there was Professor Dominic who had retired, but he was retired and tired, but he just wanted to have one last student. He told one of his ex-students that I want the best student, and for some reason he thought I am the best student, and he sent me there. And I was happy to see him because the first thing he told is, look, Shailesh, I want PhD to be student show. So you are on your own. I was happy to hear that. I did not know what was the trap I'm falling into, but I was happy at that moment because I like freedom. And after 1 year, I realized the mistake. I'm not getting any result. I'm doing experiments and I'm clueless and things like that. Because the first experiment he gave me, and I did that, nothing, no results. Means I got results, but it was not positive. We expect, he was thinking that something like this will come and that will be good. That did not happen. Negative result. Good result, but negative result. So you cannot do anything with that. It cannot be included in the thesis. It's a small thing. You do more experiments. So because it is my own freedom, so I decided to do something on my own. And then I realized the excitement in science. I was working on primer pheromones. You know, it's an interesting phenomenon. The female mice mate, and they are supposed to get pregnant after implantation. And in 20 days, they deliver pups. But somebody accidentally observed that during that time, within the first 5 days, if the female smells the urine of a new male, implantation doesn't happen, pregnancy is blocked. This was discovered way back in 1960s, and this was discovered by a lady called Bruce accidentally. And a lot of people just started doing research on that. Well, how does this happen? What happens? And prolactin pathway, endocrine signaling pathway, there's hormonal organ that is involved, etc., etc. What is the mechanism? They started doing a lot of research. And now I am left on my own. So I read a lot of papers. Reading was not a problem for me. And we had that plenty. We did not have a lot of technologies there, but these books were there and reviews were there. I read a lot of them. And then I realized, why the hell does this happen? It should be, if I understand the concept of evolution, it should be of some use. Does it actually happen in the nature? See what she does. Why not? So I designed an experiment. I took the cage. I did not take the mouse and put it anywhere else. I designed mouses cages which can be connected. I took the cage one where the female is there. I connected to another cage where the male one is there, and they mated. After that, I connected the female cage to the next male. Now let's see what happens. I used to study the behavior and things like that. And the question I was asking is, if it is all left to nature, what will happen? It is semi-nature, of course, not exactly nature. What will happen? Will this actually happen? Will this pregnancy block actually happen? So to do this, of course, you have to know a little bit more about samples and study design and all that. So I had thought of chi-square test, and I decided 30 mice should be there in each group, 30 females, and hence 30 of both types of males, 90 male, 90 mice in each group, control environment. It will take time. You are not doing an experiment today and tomorrow, so you have to plan it. So I would actually keep about 3 mice of this type, 3 mice in this type, and then try to wait. Now, there is no Excel sheet and all that those days, so I used to buy that big white charts, drawing charts, and I would draw tables and things like that, and put mice 1, mice 2, mice 3, and then okay, today our dates will be there on top, here mice are there, and I will enter what happened today. Today, after meeting, pregnancies established. After a few days, connect with the new table, pregnancy failed or again established, etc. And then there will be a final day where 30 mice has reached in each group. That's like for me festival day. Because that excitement was running all through. What is happening? What's going to happen? I was never looking at, I will be tempted so much to count, okay, 15 are there already, what is the trend? I would not want to do that. It's like the dessert you want to eat in the end of it, right? So I want to be surprised. Let's see what happens. I do not want to count now. And one fine day, I will take bath that day for about half an hour, seriously, and have a relaxed mind and go to the lab. And that in the evening only, that day I will not do any other work. I will just play around or go to tea 100 times or whatever, talk to people. And in the evening when I am alone there, I will open my chart and then start counting. In the results were that in all of the cases, pregnancy never failed. That was the result. And I cannot explain you the excitement, the thrill. Because I had observed so many things in between, there were a lot of things that were happening. No matter what, I mean, you always get the trend, but statistically significant result, what is it? You do not know, because you are seeing mice from different groups. I was consciously not biased. I know, oh, okay, maybe what happened, maybe this, maybe that. But that time you realize, actually, whenever the new male comes, it will be fighted against, and no matter what is the weight difference. This new mouse could be like Mike Tyson, and this could be like Johnny Lever, it doesn't matter. The first male will always beat up the new male. So no pregnancy failure anytime. Okay? And that means what? In natural state, this has come up as an evolutionary trend. In case the male dies, only then there is a scope. This was the interpretation of the result. During the experiments and in the final day, that excitement you cannot explain. But I was excited. I felt blessed to be a science student. Similarly, after that, I took one more experiment. A question I asked during the end of my PhD was, will bats smell? Bats actually have sonar power. They can actually send sound waves and then capture images and find out what is, locate things and all, echolocation. They can see also, but does smell have any role in finding fruits in the night? Because they forage in the night. And I did design the experiment. I found I was the first person in the world to show, I'm not boasting, but I'm just trying to share excitement, to show that bats actually smell the fruit. Small thing. In that area, we're talking about citations. So citations depend on the area of your work. In that area, whoever talks about bat olfaction cites me. And I did not worry about all these things that time. But it was so exciting to see that I want to know what happens. It doesn't use waves, it doesn't see, it can see the night because there is sunlight. But I was able to see it. I was able to see the results clearly 100% of the times it's the smell. And how did I prove it's exciting? I don't have time to explain that. So like this, and then I moved to molecular biology work. In USA there's a beautiful lab. I used to design experiments. The excitement cycle became faster because here I used to wait for months. There it was like, I used to see how many, I had to do electrophoresis equipment. I had a DNA fragment which is a regulated region. Among them, the question I was asking is which specific region is important for regulating the transcription of the gene of my interest. So we would divide these DNA fragments into 10 pieces, smaller pieces, and use them as bait to fish out the proteins of my interest. So we would run a gel where DNA alone is the run, and then DNA after incubating with proteins of our interest would be run. But I had to do about hundreds of lanes. So I actually decided to do experiments in the night because there were a total of about 10 gels in the lab. I wanted to use all of them. So I would prepare the experiments, run the experiments, and in the next day I find out, oh, okay, this is a fragment that is binding to the protein of my interest. Then after that, I look at the sequence and analyze the sequence. Today they call me a bioinformatician. Earlier they hired me ideally because they tagged me as a biotechnologist, and I was a biotechnologist. Today I'm a bioinformatician. I'm all in one. But basically I remain as a scientist who's like a child who's exploring things. The excitement continued. I did discover quite a few things there, find new things. The process as well as the finding, both were exciting. There was excitement in frustration also. There was, indeed. When experiment failed, I would curse myself. Why did experiment fail? It is different, right? Getting negative result is different. Experiment failing is disastrous. Oh my God, how can I do this silly mistake? This happens sometimes. But you eat a pizza and you eat some Coke or whatever, you don't cook there, and then the next day come, and the next evening you start again, put loud music, the wheelchairs are there, and you go around as a king there in the lab, nobody is there, put loud Kannada music and lot of sounds, my favorite songs I used to play, do experiments. There was a different thrill there. In designing the experiment, in conducting the experiment, and in actually finding something new, something very small. I did quite a few things like this. And everywhere there was excitement. However, when I look back, I just want to tell them. I want to share that excitement, and I did that. I'm left with about 3.5 minutes. What I wanted to tell in the end is something different. In the excitement of science, sometimes we forget things. Let's go back to the first experiment. I told you I discovered for the first time that all this thing where hundreds of researchers are working in the world, I found something new. That it has no relevance unless the first male dies. And I have not published that book. Why? Because I wrote the paper. When I was doing the experiment, there were times when I actually see the second male is bruised, it is being attacked again and again, it will die. if I leave it. And I would rescue it, take it out. I know the result now, so done now. You don't suffer much. Take it out. I used to do this, and obviously you see an animal being suffering, you take it out and all that. But in our discussions, in my colleagues, with my supervisor or my friends, etc., that part would never become an issue. When I wrote the paper, before it is sent to peer reviews for reviewing, there was an ethical committee which rejected the paper on the context of animal cruelty. You subjected to the male actually in nature will run away. That had no poor fellow, that had no way to go. It was attacked again and again, and you actually have said few mice died. Actually, few mice died. I used to rescue them, but sometimes I was late because I was alone and I used to sit through the night to study what is the behavior. So sometimes I was late and they died. But even when they not died, they suffered quite a bit. And I felt so guilty, I never published that paper. There's no point in making this discovery out there with this type of experiment. In fact, for different reasons, I have not published many papers in my PhD days. Publication was never my goal. But then I will come back to this. So this is the first point. Excitement is there, provided you think originally. If you think originally, each one of us can actually do so many different things. Actually, my PhD student recently commented something. We were doing a meta-analysis. So he actually suggested something very beautiful. And I appreciated that. Everybody thinks differently. If you focus on the real questions and your own thinking, you will all come up with your own ideas. And that is the gateway to excitement in science. Without that, it's a punishment for you and for the system. Friends, there are a lot of scientists among us. Just like there are a lot of policemen and a lot of politicians and a lot of teachers, etc., there are also a lot of scientists who are not true scientists. Only ego is built. They discover something, they make a paper and something like that. So it has become like a professional machine type of living where focus is always on how many publications, because without that you don't get promoted. That practical aspect is important also, but the real excitement will not be there. On the contrary, ego is built. People, I have seen scientists arguing with the bus conductor, do you know who I am? He was looking at, this person must have escaped from Nimmans or something. It's unnecessary ego. We have to develop that. Excitement is not that. Excitement is something else. It will teach us humility. It will teach us a lot of things. One of my supervisors, my PhD supervisor, I did not learn a lot of things from him, but one thing I learned is, he used to get 40,000 in an entire grant for 2-3 years. Whereas others were getting about 2 to 5 lakhs, and this guy was quite capable of getting it. And when we sometimes discuss, we learn that his philosophy is, India is a country where a lot of people are dying out of hunger. You better be careful before you use your money for research. So you show me something substantial, then I will. He perhaps told it to one of his earlier students. That is important too. In excitement, sometimes when real excitement is there, it will only come from original thinking, number one. Number two, when it comes, you could be missing something more important. The ethics, social responsibilities, etc. So those are the things that I would like to stress. There is definitely excitement in science. I am blessed to enjoy it. I was also super blessed to realize social responsibilities and ethical responsibilities. Maybe sometimes the hard way, but I have done it. And I just want to convey that to you. Thank you very much for your time.
There is excitement in the process. There is excitement in the result. There is also excitement in frustration. But excitement is not being egoistic. Excitement, it teaches humility. Thank you very much, sir. Now the discussion at the end. Now we have the second speaker, Dr. Naveen Sharma. He's a senior fellow, CGIAR, World Agroforestry Center, Nairobi, and head Resources and Planning at Bangalore Life Sciences Cluster at NCBS TIFR, Bangalore. He is responsible for developing a strategy to attract non-conventional or catalytic funds for the cluster. He obtained BSc Agriculture Honours degree from Jain Agricultural University, Jabalpur, with an OGPA of 3.97 out of 4, the highest OGPA in the university. He completed his MSc in Genetics and Plant Breeding in the same university with an OGPA of 4 out of 4, an outstanding student throughout. He received his PhD degree in Applied Biology from University of Cambridge, UK. Dr. Naveen Sharma is a research and development leader in agriculture and allied areas with 27 years of sound experience of working with prestigious multinational company Unilever and also Indian conglomerate ITC Limited. Later he had the opportunity to strengthen his experience working for international organization CGIAR. He has worked as director with an international organization, World Agroforestry Center, a part of CGIAR, which allowed him to work with the bottom of pyramid and developing solutions for your stated and unstated needs on foods and energy security. At Unilever, using his research skills in biochemistry, genetics and molecular biology, he was responsible for 3 product launches in beverages category and led some international projects with countries such as UK, Kenya and Japan. He has 15 international patents granted in US and European Union from the work carried out at Unilever and ITC. In addition, at least 14 patents full specifications have also been filed. Several patent applications are pending with the lawyers. He was considered for global leadership role in foods and R&D as well as bioscience within Unilever before leaving the organization. At ITC, as chief scientist, he was part of research management committee which took strategic decisions on building research capabilities, strategic hires, intellectual properties and so on. As the chief scientist of corporate R&D, he led a team of number of internationally trained scientists at ITC to actualize the company's vision of convergence to develop technologies to help 5 major businesses of ITC. He was responsible for setting up agri and bioscience R&D at ITC. Also, he defined R&D programs for skincare and functional foods and built capability at ITC. He was responsible for carving out a strategy on functional foods by distinguishing Indian population genetics and creating a group of address this specifically. Significant R&D achievements of Dr. Naveen Sharma include elucidation of biochemical pathway for threonine biosynthesis in tea, a science breakthrough in threonine, technology for fast and cold infusing teas for beverages business in India, Kenya and Pakistan, novel process for aroma generation developed in tea using novel wounding concept triggering signal transduction pathways for which he has obtained 3 patents. Developed next generation cold infusing teas technology for which he has obtained 2 patents. Development of product along with a team from Japan for Lipton for Unilever Japan, obtained SEAC and regulatory clearances for the technology teas. Redefined biofuel production systems using agroforestry. Development of a strategy on bioenergy within World Agroforestry Center. It is the first CGIAR center to have such a strategy. He holds 14 patents on tea and tea products, fermentation process, and so on. He has filed 14 more patents in nutraceuticals, food processing, and plant promoters. He is the author of several books and more than 50 publications in high-impact journals. He is multi-talented. Apart from a brilliant academic career, Dr. Naveen Sharma is also an avid sportsman. He has represented his university in cricket, hockey, and football. We welcome Dr. Naveen Sharma. Please come on to the dais. And I request Ms. Divya Lakshmi to present him a bouquet and welcome him on behalf of the university. The floor is yours.
2009, science, right? 2009.
Good evening. Thank you very much, sir, for inviting me here. It's always a pleasure to speak to the youngsters incite them in the area of science. I really benefited during my tenure, so I think it is a very good opportunity this university is giving to me. So for me, science, there is a simple formula for science. Science is equal to, science is equal to passion plus curiosity. And you heard about that from my previous speaker. And I define, because my background is from, I was first generation scientist who had ventured into corporate world. At the time when my father was really upset that I didn't join an agricultural university, I chose to go to the corporate world. Okay, very competitive because my colleagues were not agriculturists or agriculture scientists. They were from IITs, they were from very prestigious biochemistry, IISc, global people, and that made me think much wider. So that helped me a lot. Okay, so what I'm going to do here is I've divided my talk in different little sections. So first section I will talk about what is my excitement in science today. What's happening around the world which excites me. Second, because I think this audience must know, because you people are young and you people probably have seen only one type of research which is being done in academic world. So I want to just touch upon as to how corporate world looks into the science and how they carry out their science. So I will touch upon that. Then I will try to force you people to change your spectacle, change your lenses to see how the agricultural research should be done. Okay? Then I will come to the last part, which I developed my interest towards the end, which was like, when I became chief scientist in ITC, my chairman, who recently passed away, he asked me that the core value of ITC is let's put India first. And he asked me that all our programs have to be India-centric. So the last point which I will touch upon is on nutrition and how the area of nutrition is evolving. And I will just touch upon the whole new area which is coming up. And all this I am going to do it mainly to force you people to start thinking much beyond, taking the cue from what is the excitement currently which is happening. Can I have next slide, please? So, I don't know how many of you know about Moore's law. Does anybody know? Raise your hand. Moore's law? None? Don't worry. I also didn't know about it some 7-8 years ago, so it's not a big. So the Moore's was the Pentium. He was CEO of Pentium, and he predicted that the knowledge in transistors, which is like computer hardware, will double every 18 months. Okay, and he is living, and his prediction is still around, which is that thing is happening. The knowledge is doubling every 18 years in computer hardware. But what's happening to the life sciences or biological sciences? Anybody? Any guesses? The knowledge now is doubling every 12 months. Knowledge is doubling every 12 months. What does that mean? That means that if you are a scientist, if you want to do science, if you stick to your old dogmas, you will be irrelevant very soon. You will have to catch up with what is happening. Okay, so that is the thing. So we don't know. It's a very fascinating time. We don't know where the science is taking us to. Okay, so one has to be very focused on to see where the world is taking us to. So what I have presented, this is the left side. This is a recent, news. The scientists in Cambridge have created a life from artificially synthesizing DNA. I mean, where the science has reached, just imagine. The scientists have started creating that. I don't know good or bad, but that is the capability which people have got. Okay, so the center point I want to mention here is that how the science is now evolving. We earlier thought that we are all what our DNA is or what our genes are. And I think I have not attended Alura's talk. He must have mentioned about it's not only what you are, but what is your surrounding area or the environment is. Okay? The science is emerging from DNA to the genetics, genomics to epigenetics. Okay? So that's another thing. The third thing, which is the most important thing, I don't know if anybody has read that book, Phantoms in the Brain? Not? So this guy, V. Ramachandra, is an Indian scientist. He has conceptualized a whole new area which is called placebo effect. So that's when you do a clinical science, you give patients either the drug which is supposed to act against that disease or sugar pill. Sugar pills are called placebos. In many cases, in complex diseases also, the sugar pill starts showing effects. So why it is happening? Okay? That's happening possibly because your brain is taking over your body. So in future, we don't know where, as I said earlier, we don't know where we are going. But when you talk to the doctors can tell you that, especially the anesthetist, that what patient will give him trouble after surgery. Because if his mindset is not correct, he knows it, this guy is going to give me trouble. So your mind becomes much more powerful then. So the whole science is in journey where we are moving ahead. Okay? Now look at what is my another excitement is doing the basic science. This is a story about, again a story from Cambridge, where 4 decades of work on antibodies. They worked relentlessly for 40 years in pursuit of antibodies. They didn't give up because they had the curiosity, they had the passion. They worked for 4 decades, and what did they get? They got a Nobel Prize. And more important, the antibodies are now currently globally $100 billion industry. That's the impact. That's the impact of science. And where these antibodies are used? For wide varieties of diseases and other areas. Okay? So that's my example. Coming to the agriculture side, which I was a graduate of, we only think about plants, yield and yield, agriculture, this thing, you know. The world is now started looking at the plants as a factory. So valuable molecules are being produced. So that's another excitement. In fact, I visited a company in Halle in Germany which produces wide varieties of antibodies in tobacco plant. Actually, I was looking at whether I can change the image of a tobacco plant, which is a bad image, into a good image. And that's the root. Yeah? So that's what is excitement happening around. So now I will come just very briefly, quickly I will talk about how research in industry is carried out. So what they do is they call it 4D model. So 4 Ds are your define, discover, design and deploy. It's a stream. So a scientist is worried only about one area. So you discover, you hand over to a design team which will convert it into a prototype, and then this prototype goes to the market. Very specialized areas people work on. And I think this is an important slide for the youngsters to look into. How do you define hypothesis? When you want to do research, how do you define? You know, this is how the FBI in USA also works. So when they want to do something, they want to look into the information, how much information they have got, the reliable information. So what they call is, the formula is P equals 40 to 70. So the minimum, 40 to 70 is information. Probability of success is there when you have information which is 40 to 70%. So you have to look into, when you are designing a hypothesis, how much information is already available. If that information is within the range of 40 to 70, then you take up that project. Below 40, then you are taking too much of a risk. Yeah? So that is what. Then there are various things and people get confused. Again, this is important. That what is research? Can I do competition analysis about their product, I analyze it. Can that be a research? Can solving the production issues, where if some farmer is facing some problem and you go and solve it, can it be classified as research? Or if I develop scientific capability or I design policy, can it be called research? Or R&D program? In my definition, if others are support to research, which is like, they are necessary but not compulsory. For a research, you have to have a program where impact has to be high and content of research has to be very high. Then only, so you are answering something which is unknown. You don't know something what will happen, like my previous speaker was talking about it. Yeah. And these are certain processes I will not. And then each type of project gets classified into breakthrough project or platform project or derivative or brand support. Okay? If you only want to do breakthrough research, that's high risk because the chances of success may be little risky. So you will have to balance when you develop your portfolio. You have to have some high risk projects, you have to have some low risk projects. And not only every scientist doesn't work on one area. The whole organization takes one target and the various teams work on different targets. So now this thing I will quickly touch upon which I was talking about, looking at agriculture in a different perspective. So what one has to look into, how many sustainable development goals are there? Anybody knows here? Sustainable development goals? 17 are there. Which one is agriculture dealing with? Number 2, and hunger. Okay? And I think the agriculture research should be focusing on that particular SDG. So there are 5 challenges. Out of 5, 2 are related to individuals, 1 is to community, and 2 are ecosystems. I'm not going to read all that, but what it says is that to end hunger and ensure access by all people to safe, nutrition and sufficient food all year around, and all forms of non-nutrition, double the agricultural productivity of income of small-scale food producers, sustainable food production systems, maintain, so this is at the ecosystem level, maintain genetic diversity of seeds, cultivated plants, and domestication of animals. So these are 5 focus areas. Now when you do research in agriculture, you should see that which area you are looking into, what global problem you are trying to solve. Yeah? But what is happening is that these SDGs are supposed to be over by 2030, but the kind of progress which we are making and the kind of arrangement we have done, whatever the progress we have made, we are unlikely to achieve the sustainable development goal in ending the hunger, which is very something, which is a very, very big challenge. Why it is a big challenge? Of course, after 2000, there is a decrease in global hunger score, which is declined by 27%. But still, 1 in 9 people are still go hungry. Every 1% out of 9 are hungry today, globally. And 52 out of 119 countries have levels of hunger that are serious, alarming, or extremely alarming. And for us, we take pride in saying that India has done extremely well. Look at this, what has been written here. India is ranked 100 out of 119 countries. That's the status. That is the reality. And if you see the map of global hunger index, India is there, and look at Africa. We are not very different from Africa in terms of hunger. Yeah. Again, this thing, same thing which says that we have achieved some very good thing on food. Per capita food production increased by 26%, but we are still 100 out of 190 in hunger. What will happen in future? That by 2030, the population, global population will be 8.3 billion people, and we'll need 50% more energy 40% more water, 35% more food. It's a challenging because there is a dynamic, so I'm sure you people know about it. And these are India's challenge, which I will rush through because probably you people may have read about it. And Indian agriculture is a victim of its own success. We achieved green revolution, but that also caused a lot of problems to the whole area. But the most worrisome thing for agriculture and being agricultural scientist is that we are fast losing our relevance. The contribution of agriculture to the GDP is continuously declining. Okay? This is real cause of concern. And this is leading to many other problems of farm distress, what is called as agrarian distress, and so on and so forth. There is a potential exists for yield improvement, but is it happening? This slide I have stolen from Shesha. Is he around? No. I'm not worried. Anyway, if you see this graph carefully, the yield levels have plateaued in India. It's not going anywhere. So it's again a challenge, Population is increasing, hunger is increasing. So what do we do? So these are the dissonances. Dissonances means challenges. So the whole agricultural research cannot be looked from the yield enhancement alone. You will have to look into the land reforms, you will have to look into the policies, and so on and so forth. So you will have to use the systematic approach, the systems approach, what they call it. So far, the top portion, which is I am saying is, agricultural research does it in 4 isolated silos. Currently, you develop a variety, you develop agronomic practice, extension, and then go to farm. That's what we do. The whole thing is linear. Can we make it circular? How do we make it circular? That's theory of change. Anything which is linear, you make it circular. Yeah? So this is, what you do is, you go back to the farmer, understand farmer's field. And now I'm also, by the way, a farmer. I have some agricultural field. So when I went in Madhya Pradesh, Jabalpur, so when I first started cultivating wheat, the farmers came and, you know what they told? Sir, don't bring your agricultural university knowledge here. They were using double the seed rate of wheat. And I was telling that, why are you wasting seeds? They said, no sir, because there is a huge problem of weeds. If we use double the seed rate, then the crop will suppress the weeds. Does anyone work on, under such situation, how to improve yield? What to do the breeding? I don't think so. We are disconnected with real problems of the farmers. And what we have done is, over the years, we have destroyed the environment. We have moved away from all those areas. Again, I am challenging because you are the people, you should be challenged. In my view, there are only 2 inflection points in Indian agriculture. One was Green Revolution, and second was BT. Who gave Green Revolution? Swaminathan adopted it. Where was Borlaug? Working for cement. So we imported the technology. Okay. Who brought in BT technology? Again a foreign company. So 2 inflection points in both the cases we brought from outside India technologies. Okay, we adopted it. There is nothing wrong in adopting a good thing which is happening outside. But I am challenging you. I want to see the 3rd inflection point coming out from this group of people. Okay? So when, again, I am challenging, how to design this thing. This is all my corporate thinking which I am challenging it. So I tell somebody to improve a trade, people start immediately jump into choosing a technology. Sir, I will work on GM technology. Sir, I will do marker assisted selection. No, you cannot do that. You will have to use some informed method of choosing which technology you will use. So you will have to use metrics like this, when gene diversity and trait diversity is there. And as I told you earlier, things are moving away, GM technology is becoming irrelevant, there are CRISPRs coming, there are other technologies are coming, you'll have to keep an eye on that. And this is one example, corn. If you look into corn, you will learn corn is only one crop in the world where yield improvements are happening constantly, because the breeders or the agricultural scientists are changing the way the breeding is done every time, from double hybrid to single hybrid to adjusting the population and so on and so forth. Why can't it be done in other crops? These are all the areas which are coming up, and but there are challenges. Challenges are more like from policy. People may have heard that in China they created the twin baby out of using CRISPR technology. We don't know right thing or bad thing. We don't know. So policies should come along with technology. That's again a challenge, and that's evidence-based policy. Can we break geographical barrier? Again a challenge. Why can't Karnataka produce basmati rice of the same quality? Now don't tell me that it can only be grown in Punjab or that area because it is geographically specific. That farmer knows. You are a scientist, you should think how to break geographical barrier. I give you one example. This is one work where I got 3 patents. Where what happens is that the plant responds to environment stimuli by altering its endogenous hormonal level. And this happens through messengers, primary messengers, secondary messengers. Can you play around with them and change the biochemistry pathway? Okay? So that's one thing. So you will have to think. These are a bigger problem. Can you break geographical barrier? Can I produce the wine equivalent of French in Karnataka here? Can we? That point we'll have to do it. Look into it. Now there are, apart from breeding, doing this thing, there are technologies which are emerging because somebody is thinking very differently. Here is one example where somebody has used trehalose 6-phosphate to increase the yield of wheat. It's again an excitement. Somebody is using his knowledge, how to increase it. It resulted in, because this trehalose 6-phosphate after a concentration starts acting like hormone. There is another example. There is one product, Fortalis. What it does is it gives internal boost to the calcium production and it prevents flower dropping, thus seed formation, higher yield. Okay? Again, I'm telling you, how do you work on agriculture? You redefine agriculture from yield. How do you redefine? Can you redefine agriculture that per unit area? Today, if I am producing X ton, can I not say that I want to produce from X unit to feed 10 people? Today, if it is feeding 10 people, how do I feed 10 people? That's another challenge. And this slide tells you that currently in India, only 5.9 people are fed per acre. Okay? So agriculture is not only crop. Agriculture is also trees. Agriculture is also livestock. How do you increase the per acre number of people to be fed? Therefore, it's because I am still a senior fellow of World Agroforestry Center, I need to have this, that how evolution has taken place, that we have cut down forest, we have brought it to monoculture. Can we not go back to the original thing through agroforestry? Look into that. If you are thinking about creating solutions for people to be fed per acre. There are 2 silent revolutions happened. Very silently, much bigger than Green Revolution. Have you noticed it? And that's what my previous speaker was telling. It's the observation. It's about reading. Yeah. So the revolution which has happened is that from 1990 to 2010, what production of soybean grew by 220%, and palm oil by 300%. Nobody talked. They are controversial, of course, because it came up because at the cost of land use change. And in both the cases, one country is responsible, which is Brazil. Yeah? So they cut down the forest, went for monoculture, acres and acres. They achieved it. But this is again a revolution. So you should look the potential. Not from the problem area. Problem can be solved if you identify. But the potential you should identify. Yeah? And as the climate change, again, climate change is a big thing. What is happening is that it's also going to affect the nutrition of the plant. Because higher temperature, higher carbon dioxide, plants will fix more and more carbon at the cost of protein. So nutrition will get impacted. Anyway, so let me come to nutrition area. Very quickly I will touch upon it. I will take 3 minutes more, sir. My interest got into this thing. There was a paper which said when you ingest rice in the blood, you can find microRNA of rice. And there is a specific microRNA which binds to low density lipoprotein, which means cholesterol. Okay? So just eating things like rice, there is a genetic link there. So that means food and health are directly relevant. Yeah? Do you know that in bee, honey, how they choose an individual to be a queen? It is fed a special diet. And when you feed a special diet, the size becomes bigger, it produces, it lives longer. Okay, just diet, your diet alone. And there is a genetic mechanism for that. Same way, in ant, this publication came up and I thought that why the hell people are looking into ant genome. And then I looked at, they were looking into the Q for longevity. So there are two types of ants. One in one type of ant, when the queen dies, the whole colony gets destroyed. In another type, when the queen dies, they pick up another individual, they feed this individual with a specific diet, that individual becomes the queen, the colony remains, and then again, the queen lives longer. Yeah? So these are the things which you need to do. And again, how environment plays, the diet which I was talking, nutrition which I was talking. You are here today and your fate will be decided by what your mother ate when you were inside your mother's womb. There is a famous hypothesis which is Barker's hypothesis which talks about it. Please go and read what he talks about it. It's changed the whole paradigm completely. There are very nice experiments people have done. These white mice, black mouse. White mice is susceptible to cancer and other. If you feed these white mice, if you don't give a specific diet, it will breed like its own. White. But if you feed diet, you can change the progenies into the totally black, free of all diseases. This power of nutrition today. Yeah? And therefore, this is my last slide by the way. When you have to design a nutritional program, you will have to redesign the whole thing. You will have to look into the bottom portion of the pyramid, which is your energy, then macronutrient, and the functional ingredients at the top. And I will not summarize this in words, I will leave it to you, but thank you very much for your attention.
When you want to choose a new project, use the formula P is equal to 4270. Indian agriculture is a victim of its success. To be queen, you have to be fed with special diet. And to achieve that, we have to reach the third point of inflection, and that is in your hands. Thank you very much, Dr. Sharma. We have another dynamic scientist with us, Dr. M.B. Rajani, who is an assistant professor of humanities at NIS Bengaluru. She did her MA in Surrey Institute of Art and Design, University College, Farnham, Surrey, UK. Her specialization then was in East India Company paintings of 18th and 19th centuries, textile designs and trade of that period, and their comparison with other contemporary paintings and changes in the present styles. Dr. Rajani did her PhD in the field of remote sensing and GIS applications to archaeology at NIS under the guidance of Dr. K. Kasturirangan. She has passed a 5-year certificate course in Carnatic music theory in first class and a course on art and archaeology of the Indian subcontinent, both from Bharatiya Vidya Bhavan, UK Centre, London. After completing PhD, she had a short stint as postdoctoral associate at NIS Bangalore. There she was involved in professional activities like organizing and coordinating summer workshops on GIS for high school children, fundraising for research projects, delivering public lectures, teaching and guiding students. Then she served as an assistant professor at NIIT University, Rajasthan, where she taught courses like remote sensing and image processing, cartography and visualization, photogrammetry and GIS for humanities and social sciences. Later on, she served as a fellow at Nalanda University, associated with a research project titled A Study of Nalanda Using GIS and Remote Sensing. To her credit, she has 15 research articles published in peer-reviewed journals, 10 articles published in conference proceedings, 10 public outreach articles, and as an associate of Dr. K. Kasturirangan, she has served as a guest editor to Current Science for special section on Indian Space Program. On the topics related to remote sensing and GIS application, Dr. Rajani has presented papers in several international and national conferences held in Exeter University, UK, Beijing, China, Rome, Italy, IISc Bangalore, Rajgir, Bihar, FRI Dehradun, to name a few. During her college days, Ms. Rajani had been a bright student and was a proud recipient of Ratchapudi Kamakshi Memorial Gold Medal for Young Geospatial Scientist in 2011, Best Presentation Award for Student Session at the Indian Society of Remote Sensing Symposium at Nirma University, Ahmedabad in 2008, and Best Presentation Award for Student Session at the Indian Society for Geomatics National Conference at Forestry Research Institute, Dehradun in 2009. Dr. Rajani, why science fills you with so much of excitement? The floor is yours. Please. I request Ms. Divya to present her bouquet and welcome her on behalf of the university.
Thank you, sir, for that generous introduction. I actually came prepared to talk about my current research, but inspired by Professor Kshitish and also sir's introduction, I thought I will tell you a few words in the beginning about how I came into this field. As he said, first of all, when I finished 10th standard, when first time we are given a choice to choose what we want to do next, mine was by elimination. I had two cousins who are in the same academic level as mine. Three of us were passing 10th together, and I was by then fed up that all my family functions and summer holidays were filled with uncles and aunties asking, how much did you get in maths? Oh, he got so much. How much did you get in science? So I decided I'm not taking whatever the other two take. My cousin, in those days, or in the 1995 around, when I passed 10, 85, 90, 93 were very good marks. These days it is, of course, much higher than those. So a cousin of mine got 92, he chose to do PCMB, so I decided PCMB, no. And another cousin, because she got 88, her family, though she was interested in art, her immediate family forced her, why are you wasting your marks? And was pushed to do PCMB as well. And I decided I'm not doing PCMB. And since my second cousin was considering commerce, in case her family allows, I decided not to do commerce as well. So I took up arts, and further led me to do a MA in textiles in UK. and that journey was not as simple as going in the river. Every now and then, when I did a course, I decided to do something else, and my relatives labeled me as a maverick, I don't know what to do, and that sort of thing. But it led me to do a degree, master's in textiles. It was a dissertation-based master's where I was studying a set of company paintings. These were documentations done during the British period of how life was in India. There are, of course, many company paintings of botanical illustrations. Some of the early botanical illustrations date from that time. So, and I was studying what kind of clothes people wore, where they were produced, and so on. And I came back to India, and I was joined NIAS as a project assistant. And to my luck, it was the first week after Dr. Kasturirangan became the director of the institute, and he attended my lecture. And he called me and said, why don't you work on remote sensing? I was like, I haven't done science or math after 10 for the last whatever number of years. So he said, it's okay, you can pick it up. And I was just so thrilled that here is a rocket scientist, proverbial rocket scientist, who says you can pick up science and math that is required for rocket science. He said, you know, using remote sensing for a field like archaeology involves a lot of art. We don't have people who will readily come out who can do these two. I have been trying to see how we can apply space products or space sciences to humanities and social science. And he was interested in the subject. Why don't you take it up? I took it up with sheer excitement of being able to interact with him every now and then at that time. I had no idea whether I can do science or even learn trigonometry or required things at that time. I just thought I'll have an opportunity to see him and speak to him. And even if in 2 months he says, you're no good, I thought I'll put it in my CV that I tried working with Kasturirangan for 2 months. So with that excitement, I took it up. But I was so glad of the fascinating journey that led to it, where he also told me in the next meeting, I'm very busy, I won't have much time, but I can arrange for you to go for training to ISRO elsewhere and so on. So this led me to doing PhD in a unique field and not much explored in India, where I use remote sensing applications, satellite imagery, GIS, to study built heritage in India. So here are some visuals that I will share with you. Why this is important, why such a technology is important for studying this, and what we can get out of it. So generally history or archaeology is, we know through studying objects that were made in the past. An archaeologist extracts historical objects and studies them, examines them carefully. Here are some various pictures. The other side is an analyst is looking at a shipwreck and trying to understand the past. Here is an archaeologist who's looking at an arrowhead and trying to understand. Here are some photos of how this site, it's a building in Nalanda University. When it was first discovered, it was like this. So obviously, it doesn't visibly look like a historical site. And the objects are also different sizes. It's not just small size objects like a coin or a pottery which you can hold and see. There are architectural objects. There are landscapes. Human beings have altered landscapes in order to suit them. So traditionally this has been studied by digging some trenches and trying to get some samples and understanding a larger landscape. So archaeology traditionally has been looking at objects of different sizes. Remote sensing is from satellites. Satellites are going in orbiting Earth in the north-south polar orbit, and the Earth is rotating under it. So every orbit, it gets an opportunity to take a picture of a different area, and this gets archived and we are able to access those images. One advantage of going higher and higher is that you are able to visualize larger and larger area, and therefore you can see a landscape. Otherwise, we walking on a landscape are analogous to an ant walking on a sculpture in size, and therefore you can't, if you were ant size walking on on a sculpture, you can't see the shapes of the sculpture, and therefore remote sensing allows us to stand out of your landscape and see the shapes. So some of the uses, we can study inaccessible areas. It could be middle of a forest, on top of a hill, in the middle of an ocean. Still we can sit at our desk and study them. Studying landscape is facilitated by remote sensing, otherwise it becomes more difficult to visualize a landscape at a human scale. Synoptic view, here are examples, 2 pictures of how 2 world famous archaeological sites look from ground, and when you look from air, they look like this. So you are able to see a landscape or a site with its overall shape and so on. So remote sensing also allows us to see different wavelengths. Here there are examples of, in spite of going to a space platform, not everything we can see with our human visible wavelengths. So here is an example of using LIDAR, where we analysts are able to see what is under the vegetation, which LIDAR can penetrate vegetation and show us. Here is example closer home. This is Belur. Most of you would have visited. Belur temple is right in the center here. This is an image in a visible wavelength. This is an image in infrared, and you can see there is a circle surrounding the temple here, which indicates the old extent, which would have been a moat in this place surrounding the settlement of Belur. GIS allows us to use information from multiple geospatial layers. It allows us to see in different scales, whether you want to see at a architectural level, landscape level, larger regional level, and so on. Traditionally, when there is a site, it would be studied by doing survey on ground. Here is an example of Stonehenge, which is one of the most studied sites, because British were pioneer archaeologists who started studying Stonehenge 250 years ago. And use of remote sensing as recently as a few years ago has been able to identify 17 new features part of the Stonehenge landscape which was not known before. So that is the power of remote sensing. Traditionally there was a site and people went on ground and traversed on ground and saw what they could see on ground and studied them. Today we can plan a better field survey by doing a remote sensing analysis. And not only that, it's not just linear. A field survey leads to more lab work, leads to more field survey, and so on. So here is an example of how this field started. It was by accident. Some pilots during World War I and II took pictures of something looking like this, patterns in agricultural land, which later turned out to be archaeological sites. So how this happens is, most archaeological features are of 2 types. They would have either dug for ditches and canals and so on, or built constructions. Over time, if there is vegetation growing over there, most archaeological sites that I see and study are under agricultural land. These create patterns because the crops that are growing there, vegetation that are growing there, get stunted with the subsurface composition. In this case, they are encouraged, and we see some patterns on the surface that we can detect from satellite. Here are examples, just some diagrams to show how it happens. This is an example of a fort and a surrounding moat. Over time, it deteriorates because of disuse, or human beings have reused material for fresh construction. And if this feature happened to be under some vegetation, we see such patterns. But this is not the only means. Also, not every weather it can show such patterns. Summer can show better patterns. In some cases, in some sites, rainy season can show better patterns. And in some cases, using different wavelengths, we will be able to see patterns. And not all surfaces are only that kind. Sometimes if more material don't get removed, it forms ridges or intermittent ridges. Or sometimes these divisions become permanent markers of land boundaries and are visible as field boundaries and so on. So here is example of Halebeedu, another site which is not far. Here is the location of the temple that all tourists visit. But Halebeedu had a fort which whose dimensions are a couple of kilometers across east and west and a couple of kilometers down south. You see here how the bastions of a fort wall is still visible because of the land field boundaries in that region. Similarly, not all parts of a site is visible in one satellite imagery. We have to look at multiple satellite imagery and use different kinds of pattern recognition to identify the whole of a site. Here is another example of Somnathpura, which has again a boundary around the site within the same proportion of the temple boundary, which allows us to identify this. So this morphology also can be preserved in a city kind of situation, where when there is a barrier like a fallen fort wall, it becomes a barrier also for mobility, and people start moving along the fort wall, and this become paths become road, and sometimes cities, the settlement becomes cities, and we see these road patterns showing original layout in cities as well. There is an example of Bangalore, map of Bangalore dating from 1791, and this is a satellite imagery from 2004. Even if you see more recent satellite imagery, you're able to see these patterns. You see the overall pattern is preserved in the road that is going around these areas. Here it is just to show one such feature here where we went on ground. We have no sense of it at all on ground. There is another example like that. This is Old Delhi. So this is what was called Shahjahanabad and the Red Fort area. You can see the overall pattern and probably some of the main roads as well, which is still visible when we see it with satellite imagery. So what remote sensing does is it makes a whole landscape come on your desktop screen and it gives a sort of virtual feeling of being able to handle a landscape on your palm and analyze the same. So I'll give you one or two examples quickly. This is a map of Srirangpatna. This is the Srirangpatna fort, and here are all various sites that we know of, historical sites we know of, and here are all sites that we identified newly here. We use old maps because old maps sometimes give us valuable information. We use different types of satellite imagery, 3D satellite imagery, 3D visualization, and so on. So I won't go into the fort or armory that are more famous, but I wanted to introduce you to one of Tipu Sultan's garden, which is hardly known. So if we go to the eastern side of the island where Tipu's tomb is, just after his tomb there is this building which was a memorial for Colonel Bailey. Just after that building, we see something like this, which is a Kabutar Khana, an old Kabutar Khana on the right. And we see one more fallen one on the left. It's not easily visible. So if this is the left one and this is the right one, and the road is going in the middle. So this raised our curiosity, and we started looking what could have been on the east of the tomb. And we found some pictures and paintings of Tipu's Lal Bagh garden of Srirangpatna. Till then, we only knew of Tipu's Lal Bagh garden in Bangalore. And then using these maps and satellite imagery, we were able to identify their proportions of distance. And we visited and we found a lot of ruins in this region. And not only that, with satellite imagery, we were able to identify a garden layout, the Charbagh layout, which is a very famous Persian garden layout. And when we visited there, we saw lots of ruins. And we found like this painting which shows of the whole island, which painting done from the northeast, which shows this fort and the settlement of Ganjam and Tipu's Lal Bagh garden here with his palace. So now if we visualize this whole island, we see the fort area, the Ganjam area, and Tipu's garden area here. This is a garden which is completely gone, and the remains of the palace also, which is very few remains left. Now coming back to these two entrance towers, we saw these, and we were lucky to find this in Bangalore Museum, which says entrance garden gate Lal Bagh Srirangpatna, and it shows two of these towers on either side. So this would have been the garden gate, and these are the towers of the garden gate. Of course, there was a better preserved painting in British Library that was available to us. So these two are the only remains of this garden gate that we see. Otherwise, there is no evidence of the garden there. Similarly, here is Bangalore map, and here is the initial layout of Lal Bagh Garden. First one, the small one laid out by Hyder Ali, and the rest laid out by Tipu Sultan. We were able to do some analysis. Today, Lal Bagh is like this. And if we see the original gardens that Tipu Sultan laid out, most of it lies outside today's Lal Bagh Garden. Here are some paintings made in 1792 and both in 1792. This was done from the Lal Bagh Tower, Kempegoda's Tower, looking towards the fort and the Lal Bagh Gardens, which had an avenue of cypress trees in the middle. So using these paintings and the old map, we were able to identify the location where the painters would have sat and made these paintings, and also create a virtual reality of which angle these paintings were made from. Here is another example of a recent work where again we did on the garden layout. This is a map of Agra, which initially was a riverfront garden city. So you see this river Yamuna, Taj Mahal is here, and the rest of the area was filled with gardens, square and rectangular gardens along the river, and all these locations, gardens were belonging to Shah Jahan, his brothers, his children, and noblemen. And the rest of the city was lying further inland, and the city had two-tiered city wall. And of course we don't see most of it now, and most of the gardens that were there, we see the extent, but they have been converted into constructed blocks. So with this, I end my talk with how I started. I use art, I use science, and there is a lot of science and art as well. And I'm very thankful, though at the beginning when I started, I don't know where I was going, but it has been a fascinating experience, and as Professor said, I'm still a child in what I don't know, and still a child in what I know as well. Thank you.
Archaeological survey is like ant moving on a statue and trying to find out what it is, and it is unable to make out the structure. It is like a worm's eye view of the statue, and remote sensing is taking that ant in a satellite to the sky and showing it what is there, and ant can easily make out the structure of the statue, and that is bird's eye view. Fantastic talk. Thank you very much. Now I request all the three panelists to come out to the dais, please. It's very interesting. One who started with a study on mice, the other person from agriculture background, and the third person starting with textile designing and going to space. And very apt for this occasion. Now it is open for discussion. We invite the students to interact, to ask questions. And we should see that excitement at least now.
I'm Manjunath from 3rd PhD in Agriculture Technology. I have a question for Dr. Kshitij. So about the rat experiments. When you said you introduced second male, and the both males are fighting, what the females are doing? Whether they are supporting first male
sorry to disappoint you, female is not bothered. Actually, the female mouse would go and explore the new mice always. Okay? It would always be interested in new mice, and the males will keep fighting. The male mouse would be interested in the beginning, and then when it sees the retaliation from the first mate, then it wants to run away. That's what happens.
Sir, actually I have one more similar question to that, because even in insects, I'm an entomology student, even in insects we see the same phenomenon, something called sexual selection. Usually in stag beetles we see that. What happens is that usually two males will fight, then they'll approach a female. So have you ever came across any instant that the first male which mated with that female died, and the female approached the second male?
So in the laboratory condition it wouldn't happen, but I'm not sure if what I'm referring to is actually sexual selection. This is in the course of evolution. If, for example, if the evolution, sexual selection is about in a way selecting the strongest one. So it's actually working against it in the sense, if the first male for some reason was environmentally not fit for that ecosystem, it would die. Then only it has an option. This is a very strange situation we don't see in any other species. So it's not rat, it's mouse actually. We don't see this in rats. And definitely we don't see it in human beings. So this was a peculiar situation as to what would it mean. So in terms of applied values for agriculture, what we were proposing is if we can exploit this to actually control the pests. So that's how it was already in my mind that time. But yes, so we don't see exactly like that in other species as well.
Specifically, certain, the whole area which is emerging is called epigenetics. So the certain nutrition which are like, B12, for example, which is a methyl donor in vitamin. And by the way, Indian population is deficient in B12 globally, within India. So that's one reason that Indians are becoming more and more prone to diabetes. It's a very clear-cut evidence which are coming out. So that slide was not meant to show that white becoming black or vice versa. The slide is showing a very elegant experiment using animal model which can be eye-catching, but the underlying thing which is wanted to show that how nutrition can prevent the offspring from being susceptible to cancer and being less obese. So that is the power of nutrition which that slide was meant for. So whole area of epigenetics is being talked about. So that's a new area. So my purpose was to tell you people that what you have learned, the area is changing very rapidly. So you will have to keep an eye on what is happening. Even if you are an agriculture student, you should look into what experiments people are doing in cancer. Can you relate it to your agriculture field or immunology or some talk about mice experiments?
Hello sir, I'm Priyanka I'm also from entomology department. So my question is to you, in a similar perspective. So do you believe that nutrition can change an organism's genetic makeup?
Yes, again. So what happens? There are 4 DNA bases, A, T, C, G.
Right.
Okay. So with the nutrition, methyl group goes and gets attached to the cytosine, and it gets with cytosine methyl. So C becomes G then.
Right.
Okay. And then so there is one thing which gets changed. When the gene is changing, Yeah.
Okay, so do we have means that
So behind donors, for example, I will come back to it.
Right.
When you are smoking, there are a lot of epigenetic changes are happening. But at the same time, if you are taking supplements, your cancer progression can be prevented.
Right.
Yeah.
Right. So in that
It's
case,
at a regulation side, gene regulation side.
okay. So in that case, means do we have evidences that we are offering different kind of nutrition, and when we are looking at the sequence of the DNA, then we are getting the change. Is there any evidence on that?
Yes, very solid evidences that methylation patterns can be recombinant. So there is a thing called global methylation. You can identify which genes are getting methylated. In fact, nowadays people are saying that there are not only 4 bases, there are actually 6 bases or 8 bases. Yeah. So the whole thing is changing, and that's only because the methylation of DNA bases we are talking about.
Right. So why am I asking this question means actually in my lab we have designed some experiments on with mice. So there is a particular mite called Neoceras longispinosus. So what we are trying to see is we are trying to feed that mite with different other prey mites for almost 1 year, and now we are trying to look for the change in the DNA, if there is any change in the DNA. So I found something very interesting. It's related to the way you told. So that's why I just asked.
No, so you simple thing is you do the global methylation of your control versus maybe you can.
So I'm a bit surprised actually. I am not very sure if nutrition would actually change genetic makeup so directly. But yes, any environmental change, it has a potential to change the course of the direction of the evolution. Okay? In what direction things are going. Potentially yes, nutrition, because how does mutation occur? Not only methylation, even otherwise. The mutation in our body happen because of the environmental things, either radiation or the food toxins, etc. we take. So it's not food doesn't mean only the vitamins and the type of carbohydrates and everything. In food we take a lot of things, and they have the potential to alter our DNA. But a specific type of food content might eventually lead to something else differently. But I have not come across a study where, for example, if you go on rice, will you see its value change? I do not know of that type of thing. So that is something my take on that. So we do not know if you are looking at a specific directional change because of one particular type of diet. That I am not really sure.
Right. Thank you, sir. And my next question is to ma'am. So most of the time we have listened to the journey of scientists in science. So you are somebody else means who are in arts, and then you came to science. Just out of curiosity, I wanted to know means you had degree in Master of Arts in textile. So means how did you get the degree, that MSc or PhD in a science subject?
Well, it was not easy. We had to go through. I was registered with Mysore University. We work in MIAS, but MIAS is an award degree. We are affiliated with various universities. So my degree went, my application went to Mysore University, and they started in Department of Archaeology, and my guide was in Department of Physics. And I had many other problems with my application because my background was not suitable. So as a result, when I sent my PhD synopsis, they took 2 years to get back to me. I didn't even know in those 2 years whether my work would finally reach a PhD. But I must thank for the support my guide gave. He said, you do your work, that's what you can do. And you work, you publish, and if you have enough publications, peer-reviewed publications, that will give you strength. And if that is there, I don't think even if your PhD doesn't come, it will be, it's enough to hold you. So that's what I did. So I went for some international conferences. I did a few publications, and then Mysore University had to hold a special committee, multidisciplinary committee, to discuss whether, it's not especially for me, I'm sure there are other applications. So it had to go to that committee, and they had to invite some extra people to look at my this one, and then they decided to accept my application. by which time I was already almost ready to write my thesis and so on. Within a few months of my synopsis getting accepted, I was ready to submit. But at that time, that uncertainty was very hard. But it happened. So,
Thank
but
you.
I'm a recognized guide now in the same university.
Myself Harika from Department of Agricultural Economics. Sir, I have a question for Naveen. Sir, I have a similar question regarding that mice slide. You have shown that the mice has changed the color from white to black because of nutrition. Does humans also have the ability to change their color just based on nutrition? Like, as per your knowledge, are there any evidences?
No, not. So, in mice, the color, I don't know about the color. They are maybe significant, so I'm not the expert in mice. But I have not come across that. That slide is just to show you the power of nutrition. And if you, the whole new area of epigenetics which is coming up, so skin color doesn't, in human beings, will not change. Yes, in mice it did. So there is a reference. The presentation will be there. There is a reference. Please read that publication. And it's a landmark publication which opened up the whole new area of nutrition, especially for maternal nutrition, what is called. So I work for Unilever, so I will not comment on that. So again, there is again a thing called, your potential in human being. So when you are exposed to sun, the body part which is unexposed and body part which is exposed, that is a potential of achieving the fairness. So your original inherent capacity to be fair versus what you have become after exposure. That's what you can revert. Beyond that, you cannot revert. Any treatment you do it will be irreversible.
Thank you, sir.
So don't try to do anything.
Thank you so much for the wonderful talk. My question is to ma'am. Ma'am, I heard that long before, the science and art was it was not like today, in two different streams. So do you think there is a barrier between art and science? And if it is there, what could be the possible reasons and how we can break it? Because if art is mixed with science, it could be more exciting, right?
Very true. I often have to, for my own work, refer to works of, say, some astronomical treatises, like Brihat Samhita by Varahamihira. If you read that, Varahamihira and Aryabhatta are known as astronomers or mathematicians. But if you read that, you will see how much of artists they were, how much of astrologers they were, how much of general observers they were. They observed everything and they were. But it was a time like that. I feel division also happens because our university system is designed like that. We belong to such department, within such department we belong to such group, and so on. Forget about science and arts. Even if we go to a university system, they consider history and archaeology as two different things. And if you have to use both, they consider that as multidisciplinary, which I find really absurd. I mean, how can you do archaeology without history, or how can you do vice versa? So it's unfortunately, I think, the way we slot and how university as a system has developed and where it gets slotted. For instance, in India, very often archaeology gets slotted under the Department of History. In America, archaeology is slotted under the Department of Anthropology. So the lot of archaeology study coming out of America will have a very strong anthropology base and anthropological methods to use, and so on. So I feel it's in the basic degree level, postgraduate level, what they are taught, what the syllabus becomes, that sort of makes them go into a vertical rather than a lateral shift. And I think in India, I'm sure it was like that in the West, but they moved out of it. But in India, we are still very scared of doing lateral shift. We are very scared of taking gap years or gap months between 2 degrees. Before we finish one degree or one course, we want to know what we are doing. In my case, at least, all the best things happened between when there were gaps and I didn't know what to do. So I feel one thing, the university system still has that kind of very vertical way of looking and lack of freedom to do lateral shift. Even in my case, it needed somebody very influential to push the case that it is worth doing and so on. It's not available for everybody as a way to shift fields or do multiple fields. In India, there are very few multidisciplinary institutes which allows and encourages such things. So, but it started happening and hopefully will be more liberal in future in letting people do more than one field or more than, multiple fields. And also education system should allow. But I think we have started streamlining by making separate departments and making it difficult for people to cross across and collaborate between.
I just wanted to add something to this because there's something interesting. I'm not very sure if we need to really force arts and science mixing and things like that. But yes, people's interest should be really more valued than anything else, and that shift should be allowed. What is interesting is, perfect, as Madam also told, even within science, the shifts are not like you are a zoologist and you are a veterinary science. They always look at each other from as different species, and you can see this in medical fields actually. There is a professor who has come from medical degree and one who has not come from degree as a biochemist. There's a lot of difference between them. So they always want to discourage we are superiors kind of a thing. And IBA started a bioinformatics diploma first. We were the first in India which would allow anybody from any science field itself to come into bioinformatics. That itself was a lot of, if you are a bioinformatics student, means you have to come from biology field was the notion. We changed that. So today in IBA, now it is becoming everywhere. You can be from computer science because you need computer science skills there. So at least we open to a lot of science fields. That itself doesn't forget about science and other aspects. And science versus commerce and arts. That type of barrier shouldn't be there. Just quickly, one of the reasons is people do not have the innate ability to recognize talent. This publication-based assessment or some other CV-based assessment or student selection based on this, it is difficult. It requires genuine interest and genuine talent to recognize talent. When that is not there, this is the problem that happens. People just go by books, rule books.
My name is Karthik, and my question is for you, ma'am. When you said you are using satellite images to track the structures, are we tracking only the structures which are on the surface, or can we see what is underground?
Yeah, it depends, of course, on the sites that we are studying. If there are a lot of surface activities that has happened, like it's a city or it's a road that has built up, it could have destroyed what is there. One example is very close here, Chikkajala, there is a circular fort wall sticking out of our airport road, which was just chopped because airport road had to be widened. So then you can't find any evidence of the chopped part. So if there is surface activities happening, new cities, we can't see any pictures. But if we go more rural areas, we do see some surface indications of subsurface buried material, which we can see with optical imagery. But there are other technology which allows penetrating vegetation or penetrating few meters of soil, depending on soil moisture condition, which we can also see. So sometimes we have to use ground-based remote sensing rather than satellite-based remote sensing to see more deeper subsurface features. But it is a different technology that one has to use.
One more question. The thing is, it's more of curiosity. We usually hear about these kids having, when usually we used to have these secret passages leading out of the castle. They usually have stories. 50% are saying there is some underground hidden passages. Have you come across any?
Yes, there are. I recently had some journalists coming up and asking me if I had done some work on Talakadu, and there are some legends about Talakadu having underground passages and Tipu Sultan having built underground passages and so on. There is no doubt underground passages have been used for irrigation and sometimes they have been used for spying and so on. But most often these get destroyed over time if something is constructed on that. And if that gets destroyed, we are not able to see them.
If it is intact, using satellite imagery, we can track it.
Yes. Again, as I said, surface condition play a big role. If it is vegetated, maybe agricultural or maybe some other kind of plantation, we have a better chance of seeing them. If it is constructed on top, we have less chances.
Panelists, my name is Dishant. I'm from Extension Department. My question is to Lakshmi sir. So in your experiment of mice, you said that after mating, pregnancy would be detected by you. How would you detect the pregnancy in the female mice, whether it is through urine test or through behavioral signals?
Yeah, so you do have a lot of biochemical tests, but what we used to do is first, if mating has occurred, and there is a vaginal plug that we can see visually, so it's very easy to do it. So first in the morning we will check that. But yes, later you will see a lot of other symptoms and things like that. And whether implantation has failed or not, for that we will have to do surgery and then test that. In this case, prolactin hormone and estrogen levels could also be used. In biochemical test, if you want to do it correctly, these are the tests we do. But the most important clue for us is it wouldn't mate again. If it is pregnant, it wouldn't mate again. That's a clear indication. So if the female is pregnant, then you would not see that. She would not get in contact with the male again. And male would not be interested also because of the hormonal and pheromonal signals that he gets from her.
Sir, can we able to target plants? Can we able to target plants?
Talk to clients.
Communication with plants.
You can talk. You can talk, but whether they are listening or not, I don't know.
You said I can replace the plant.
Yeah, please.
Yeah, now ample research is available. Plants can speak to you. Don't tell me as to what language they would speak. It's all about these molecules, and you can perceive those molecules. And if you plot it, you can know that you're talking something. Either the plant is responding or not responding. If it is responding, it can be plotted. So the things have changed. The plants have sense, and plants have much better intelligence than human beings. And that is that everybody is talking about that. There's a different science which is evolved right now, and all those people who talk about plant intelligence or who do research about plant intelligence are called as plant neurobiologists. Things are changing.
Sir, is there any books available?
Hello?
Any books?
Yes, it's available. You can go to internet and see papers, published papers.
Can you pull them?
I have hundreds of them. If you come, I'll give you.
So this is a panel discussion at the Liberty of Badri. So talking is one word that was used, intelligence was one word that was used, and both these words are anthropomorphic. these are the words that we created, we give the meanings. Okay, so it is better. So even in the case of human beings, we are not very sure what is intelligence. Since Cyril Bird's saga, even today we have not decided what is intelligence. It has not been, it's a very slippery concept, it has not been possible to define. But what is important is that plants also behave like animals. So they respond to the environment and very subtle, in very, very subtle ways. And that is what we are talking of as behavior. They may not possess a central nervous system, but they have other mechanisms to respond to environmental condition, to other neighboring plants, and they communicate using, as he said, chemical signals.
This is what I was trying to say. When you say a dog, suppose let's say you're proposing that I love you. Okay? You sending a kind of signals. The plant can tell, okay, this person is loving me. Or if you want to tell, I'm going to kill you tomorrow, it also responds. Okay? So the kill and maybe sounds different in different languages, but the mind kind of mental processing which you're trying to do is the same. Okay? So you don't need language, barrier, color, cars to form it around. Dog is not what.
Sir, one more question. Just to add to your question, means if you answer, you are searching for books, so you need not to search for books. If you go to YouTube and type Google Tuning, so it will. They actually Google what they are doing is means the plant signals they are trying to associate with codes, and that codes will speak for you. Means if you ask the plant means what kind of stress you are, if it is in water stress, it will tell you that that there is a speaker and it will tell you that I need water for that. I need water to survive. Give me water. So yes, plants can we have a technology now that yes, plants can communicate.
Can I know when we started this program, like this thing?
No, you should be very proud. The first person who told the world 100 years back.
Yes.
Jagdish the whole world is telling he was a pioneer. When he did it, people told him that it's hoax, and some people, when he was wanting to demonstrate, they tried their own kind of methodology to see that what he's talking is wrong, etc. But they played a foul on it because it is the first time to be thinking about it. And he brought all that. Now even Darwin spoke about it. When Darwin spoke about it, people thought he's a very, very old, senile man talking rubbish. And even now, the classical botanists, they think all those people who talk about intelligence, what Dr. Chandrasekhar has talked about, he's been talked everywhere. Even in CBS, how plants respond to the surrounding. Why do you think the plant do not understand a human?
Yes, sir. I know that the plant can understand.
Why do you think plants do not understand a human being? They know there's a person called
yes,
human.
sir.
There's an entity called human being.
Plants can understand. So how to communicate? That's the thing.
How to communicate? He said now there's a Google kind of thing.
Actually, I have seen that project about the project.
Yeah.
They have mentioned in April, March again, like to maybe make me like April Fool. So I thought it was not.
Don't take it so seriously. Some things could be fun, etc.
Yeah. Sir, and one more thing is,
so a series of papers have been published in Nature on plant behavior. Just Google, read, and as actually said, it's best to learn by yourself. Okay? Because full course content during the class.
The simple thing is, all of you have a camera.
Yeah.
You have a camera which is a fast motion, slow motion. What is that camera? No, Hotman. You have slow motion and fast motion. What is that? Put on a timeless camera to any plant here, the whole day, run it, you see the plant has intelligence.
Sir, one more question. Sir, you said
go ahead.
Plants behave like way of animals. So, sir did experiments with mice now. Sir, have you ever tried to talk with mice?
Sorry.
Try to talk with mice.
Yeah, have you heard it?
So, please sit in. So I think if there are more questions, we will go to the next question, to the next person, then we'll come back to it.
I told about it.
Yeah. So, but I'll answer this, okay? But I also wanted to comment on this generally. See, in science, it's very important to have scientific temper, okay? So, You ask a very specific question. Science research always starts with a very specific question. You find an answer. And from there, when it comes to public, there are a lot of exaggerations sometimes. So you have to look at the evidence, what is proven, okay, versus what is actually a hypothesis, what is the theory, etc., etc. There are a lot of things in between, okay. So whatever question you ask, like our colleagues here and some of your friends, they suggested some resources, okay. For example, there is a simple thing, like there was a recent research paper which said 40 push-ups, those who do 40 push-ups, they don't get heart attacks in next 10 years. You have to read the paper to believe it. Everywhere internet, it was a big thing. There are people who are waiting to make big news, they wrote it. So when you read that paper, actually the best correlation, statistical correlation, was with the age. The only people who could do 40 push-ups were actually having a different age group than this. They hid it in the paper. And it came out as if something like this. So what you want to say, what the researcher wanted to say, they have very smartly hidden it. Okay? But those people who read the abstract jumped on and wrote in internet news, and everywhere it was there. It was going in Facebook, it was going on everywhere, and there was YouTube videos and things like that. So first thing first is that, okay? If you ask me, can I talk to mice? If I had tried to speak to mice, my PhD guy would have removed me from that. So you cannot talk to other person. ಎಷ್ಟು ಜನ ನಿಮ್ಗೆ ಬಂದವರು ಇಲ್ಲಿ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡ್ತಾರೆ ಹೊರಗಡೆ ಬಂದವರು ಅವ್ರು ಬಂದ್ಬಿಟ್ಟು ನಿಮ್ಗೆ ಹಿಂದಿಯಲ್ಲಿ ಮಾತಾಡೋದು ಅರ್ಥ ಆಗುತ್ತಾ ಬೆಂಗಾಲಿಯಲ್ಲಿ ಮಾತಾಡೋದು ಅರ್ಥ ಆಗುತ್ತಾ ಸೊ ವಿ ಹ್ಯಾವ್ ಡಿಫಿಕಲ್ಟಿ ಇನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಅದರ್ ಆನ್ ಹ್ಯೂಮನ್ ಲ್ಯಾಂಗ್ವೇಜಸ್ ಯು ಕೆನಾಟ್ ರೈಟ್ ಯು ಗೋ ಟು ಜರ್ಮನಿ and try to speak them in Hindi or in Kannada or something, will they understand? They won't. So the point is, communication is one thing, talking with language is a different thing. Okay? So it's a complex matter. I was perhaps smart enough not to try to talk to mice in actually any language. We can discuss more, okay? So you have to understand the borders between fascination and simple things and what we are here talking about science, right? So let's talk more about science and talking to mice, and these are fascinations, and I don't know why did that question came to you, because you thought of talking to plants. You are asking me if I could talk to mice. It's not so relevant for the current discussion.
You raise the mice, then you will know. Then the mice today, then you will understand that it is talking. Talking is just not verbal.
Panel. My question is to madam. There is an old saying in Kannada, Nadi Mulla Rishi Mulla Udupagam. Can you use satellites to track the source of the river?
We can use satellites. Of course, they have their own limitations. We have high resolution, low resolution satellites. So what they can show us is limited by what their resolution is. For things like such as rivers, we usually don't use very high resolution because it is too detailed. As long as you can have features that is showing a sign of a river that is as big as 5 meters or so, as wide as 5 meters, we can trace. But if it goes further, smaller area, it is difficult to trace. So, and usually such signals are, such signatures are traced because where there is water, there will be more vegetation and healthier vegetation. And because of that, you trace. And if there is no such signs, it becomes difficult to trace.
My question is to you, ma'am. You have shown that from a wall, how you people have found that from which position they have drawn it. That you were able to know that. So I want to know if you go to an unexplored place and if you don't have any sufficient historical data, in that case, how difficult it is to connect the dots, if I hear anything?
It depends. Not every site reveals enough of information. We use old maps sometimes, some records of some travelers. some British records of people who went there, and if they have said that there was a wall, there was a fort, then we try to look at satellite imagery for showing such features. And it also happens that sometimes there are false calls, and when we go on ground, it is something else, more modern feature. So satellite image analysis doesn't replace field visit. It only supports or guides us to a particular place. So it is not that I can't say that we can study without going to the field at all. So it is necessary to use. I mean, one should use it as an extra tool to do a better judgment of what it is, rather than replacing old traditional methods.
This is a kind of general question for you, all of you. Today I got excited with all your talks, and also I'll be excited about my work, and it will retain at least for 3 days. If the graph comes down. So does it happen with you? How do you sustain the excitement throughout your experimentation?
I thought when you asked the question is open to everybody, we are going to fight for the mic. Okay, so I don't know why we should contain the excitement. Why do you want to contain the excitement?
Well, it happens.
Yeah, let it go. What's the problem? For me, I wouldn't want to contain the excitement. You rarely get that with all the things around. If you get an excitement, hang on to it. I think that's what is my suggestion. You don't need to contain it. I mean, don't be like Archimedes. I mean, you know, not to that extreme. But we actually, I mean, people have expressed their excitement in different ways. I think that's usually within the reasonable limits. Be happy. That's my suggestion.
Students' excitement is more like volatile. So it will go.
Everything is volatile. I will take care of it.
So in my view, you are right that the excitement is temporary. But anything which is temporary, if you train your mind to do it on a regular basis, then that excitement becomes habit. What you will have to do is that either the docs are there or whatever, you go back home, write down today what you have learned. Not necessarily the content, but the management of those content. And invariably you go and check that, then your excitement will prolong it. So that's what my message is, that's how you can prolong your excitement.
It's okay. So just a correction. Also, I agree. So I thought you want to curtail it, and I want to know why you want to curtail that. That's how I misunderstood the question. I mean, excitement sometimes these things happen. So, yeah. So how do you want to prolong it? I think what's that said? I agree. You should do it more. That's a natural thing to do. Whatever you like, you try to do it more, and you engage more in it, and that's how we do it.
Yes, it regularly happens. Sometimes it happens in days, sometimes it happens in hours. You may have a very exciting moment now, and within a few hours you feel you had made some mistake in understanding, and it goes down. And again it comes back in a few hours. So it does often happen to me, and I feel one way is to keep in touch. I often find that if I go for a longish holiday and I don't have a sort of some kind of intellectual stimulation, I become extremely bored and upset. And my family says, go back, go and attend some lectures and so on. But the other thing somebody sent me when I was a PhD student, it was an article in New York Times called Disorientation Begets Creativity. So around the same time, another professor who used to work in our institute, who was doing image processing, so he used to develop this very complicated algorithms for this. He, around the same time, said something similar to this concept of disorientation begets creativity. He was saying how he would sit in front of his computer trying to find a solution for something, and he wouldn't get it. And then he would decide to walk out of that environment, and the minute he's gone out, he would get it. So he said computer has a stupidity range around it, so if you go out of that range, you get it back. So in that case it was a few minutes or few meters out, but this happens with everybody at different, and it could be a geographical range, it could be a mental range, it could be a few hours, few days. So sometimes having multiple interests and just going out of what you've been doing and which has sort of brought down your excitement, do something else for a bit and come back. It makes you take refresh and do better for both of what you are doing. That is my secret of carrying on.
And one thing which I will add to sustain your excitement is go and tell as many people as possible. Then there will be peer pressure on you to continue to achieve that.
Not you would say go and drink a cup of tea created by you. Anyway,
there is one more question by Dr. Chandrasekhar. Before that, I would like to make an announcement. This panel discussion there was a live webcasting of this program in the YouTube, and if you want to watch it again later on, or you can give this information to other students who couldn't attend this panel discussion because of some reason. They can watch this in Science Week 2019. YouTube, Science Week 2019. You can watch it again afterwards. The last question by Dr. Chandrasekhar.
Just talking about science and scientists hiding vital information from their papers, and that falling into the hands of journalists leading to hype. So that's very well put by you, Shailesh. So there are also myths and fiction in arts and crafts. So since you said you have worked on art of the company textiles from the company period, I just want to know whether how much of fact or fiction is that a meter of cloth can pass through the ring and then malmal sari can be packed in a matchbox. And that's one question. The second part of that is how much of this our weaving techniques and are from Persian influence and how much of Indian influence, native Indian influence?
I have, even I didn't believe about this going through the ring or matchbox. I don't still believe matchbox, but I have myself seen some very fine silk from China which can go through the ring. And I have also seen, there is this other legend about Damascus blade cutting through a silk, and that also is quite true. I mean, there is this legend of a king, having a competition of whose sword is most this one, and somebody cuts a brick and this and that, and somebody throws a silk and cuts it when it is flying, silk cloth. So those things, of course, it's poetic, it is little exaggerated and all that, but they have produced some very fine malmal cloth, especially in Gujarat, Rajasthan region. And as far as Persian influence, I see is not so much in the weaving or spinning of the cloth. It is more in the motifs and printing and embroidery and that sort of thing. As far as malmal and those prints are concerned, yes, of course, if you look at carpet weaving and all, yes, then influences have come from there. But cotton and prints, it's more the motifs that have come from there rather than weaving techniques. And still, I feel cotton and silk, the fine weavers are from China, traditionally from China rather than India. And regarding these myths, there are many myths that gets connected with sites, archaeological sites. And every time I give a talk about any site, those myths keep coming up. There is, of course, this thing about Talakadu and the curse and so on. So I once, when my first paper came out of it, I had a journalist who came and interviewed me on how we did the work, and he did a very good report of what the work was. But he added one last line saying, thus this work scientifically proved that the curse worked. So that was the last line twist, which we never spoke about the curse in the interview. But that happens with journalistic interpretations.
Before winding up, there is one more announcement. Tomorrow afternoon, after the valedictory program, there would be a live music concert here, classical music concert here by the third year student, BSc Agri student, Rakshit Gowda. He has already given concerts, kacherigalana balashtu kottidare avaru horagade, and you have heard him during the Carnival, okay, Carnival 2019. He has a beautiful voice, very mellifluous voice. Don't miss it tomorrow after the valedictory function. At Chowkidar will be there outside. So in the same hall, he will be giving the concert. The three panelists, your talks were simply scintillating, thought-provoking, and fascinating. And on behalf of the university, on all the student friends, we thank you very much for the order of our class. I request Dr. Satyanarayana and Dean PGS to present them and mementos, please. Dr. Kshitish Acharya, Dr. Rajni, Dr. Naveen Sharma. We sincerely hope that we'll have more such opportunities to listen to you and having interaction with you. Thank you very much.
Shikhar Moti, I think he has spoken a lot. He doesn't drink tea or whatever, but I don't know what he does with the cup we are going to give him for the
And we also thank Dr. B.N. Satyanarayana, Dean PGS, and Dr. K. Chandrasekhar for organizing all such panel discussions every day of the Science Week. Thank you very much. Thank all the faculty members and student friends for making this live and exciting. Thank you. Thank you very much. Tomorrow morning, 9:30, the same venue.